Hello, 7th graders, and welcome to lesson 15.3, our second lesson here in probability. So we're going to be talking about experimental and theoretical probability today. And we actually got quite a few different objectives today. So our objectives are, I can find relative frequencies. I can use experimental probability to make predictions. I can use theoretical probabilities to find quantities, and I can compare experimental and theoretical probability. Skipping warm-up, I'm on with me. So how can you use relative frequencies to find probabilities? Well, first, before that, we got to understand what relative frequencies are. So let's go ahead and, okay. So we're going to first talk about your experimental probabilities. I don't think I have a pen right now. There we go. All right, so my experimental probability is probability that is based on repeated trials of an experiment called experimental probability. So a number of times the event occurred, number of times of trials. So maybe you're taking a dice and you want to, see how many times you can roll a 2, okay? So every time you roll a 2, maybe you roll 3 2s, so you'd have the number of times that that event happened, and it took you 13 tries to get 3 of them. Okay, so the total amount of tries. Again, we always put it as probability event, but sometimes we'll just leave it as a P. So let's go ahead to the first one. It says the bar graph shows the results of rolling a number cube 50 times. So again, that number cube, remember your number cube just means dice. Okay, so you're rolling a dice 50 times. What is the experimental probability of rolling an odd number? So this is kind of that probability we were talking about before, where we were talking about odd numbers, and it's just what was your chances of rolling an odd. This time I actually took that and did an experiment of it. I did it 50 times. I want to know how many times in this experiment I rolled an odd number. So I'm going to use my 1 still as an odd. I know sometimes, again, like I said, sometimes people don't consider 1 as an odd. And we'll take 3 and 5. So again, your total amount of outcomes are in the bottom. So how many times did you do the experiment, or how many trials? Well, we did it 50 times. And then I'm going to take a look at how many 1s, 3s, and 5s there were. So for 1, we got 10, okay, 10, and we're going to add them all together. For 3, we got 8, and 5, it looks to be that we rolled 11. So if I add those all up, that's going to be what, 24 out of 50. Can we simplify this? I think for sure we can. I think we can go down to 12 and 25, so dividing it in half. Can I divide it any more than that? 3, maybe by 3. Is 25 divisible by 3? No. I think that's what our answer is going to be, okay? Remember your probability, we always simplify it. So we're down to 12/25. Please don't leave it as this form. Please simplify that ratio, okay? So you have a chance of 12 out of 25 to roll an odd. Or when we rolled the 50, it was 24, which was almost about half, because in theory, this is half the numbers. 3 numbers, there's a total of 6 numbers, but it's almost half, but it's not quite. All right, example 2 then. It rains 2 out of the last 12 days in March. If this trend continues, how many rainy days would you expect in April? So if we think this trend is going to continue on, we want to know, what are we going to be able to expect in April? How many days are going to rain in April? Well, let's create our ratio first. So 2 out of 12. So that would be 2 out of 12. And this one, we're actually going to use a proportion as well. Okay, so we're going to set them equal, and we're going to come up with a ratio. We don't know how many days it's going to rain in April yet, because this is like you were living back in March. Okay, April hadn't happened yet. Or you can think about it right now, being like, okay, well, June hasn't happened yet, so I don't know how many days it's rained. We want to know, though, how many days are there in April, okay? I always do the knuckle trick, if anyone knows that trick. So anytime you hit a knuckle, it means it's going to be a 31 day. Anytime you're in the middle here means it's going to be less than that. I mean, February is the only one where it's going to be 28 days, possibly 29. But then everything that hits an actual knuckle is going to be 31. Anything in between is going to be a 30 day. So if I go January, February, March, April. So April is going to be in between the two knuckles, so that's going to be a 30 day month. So I'm going to put 30 on the bottom. This one isn't quite as easy to just like multiply over, so let's use our cross multiplication. I'm going to solve for x. So I'm going to have 12x equals 60. We're going to divide each side then by 12. I'm going to grab my calculator here. I think that's going to be 5, but I want to make sure. Yep, it is 5. So what can you expect in April? I would say 5 rainy days. Okay, if this trend continues. Let's keep going. All right, looks like you've got some problems to try here on your own then. So again, we're just talking about your experimental probability. So example 1 is you're going back to example 1 and then telling me what's the probability, the experimental probability of rolling an even number. And then 2, you're talking about clothes company, and it looks like you've got some jeans. They want to know how many defective pairs they're going to expect if they make through 5,000. So this is a lot like problem number 2 that we just did. Okay, so take the time, pause the video. When you are done, come on back. We'll talk about the answers. Alrighty, coming on back. So when you go back into example 1 and you count up all the even rolls that you did, so you rolled 2, rolled 4, rolled 6. Out of your experiment of 50, you had 26 that were even numbers, so we want to simplify that. I simplify it down to 13/25. All right. In number 2, I set up my ratio, set up my 2 ratios, set them equal, set them as a proportion. So when the inspector finds 5 defective pairs in a shipment of 200, if that trend continues and they make 5,000 or they send 5,000, how many are going to be defective? So 5 out of 200 equals then x out of 5,000. This one I did cross products, cross multiplication, your butterfly, and I get an answer of 125. So I would expect that 125 of them have some issue with them. Maybe it's a defective zipper, pant legs are off, whatever. There's no pockets. I don't know. All right, so now we're going to move into talking about your theoretical probability. Okay, your theoretical probability is when all possible outcomes are equally likely. And of an event, a theoretical probability of an event is the ratio of the number of favorable outcomes to the number of possible outcomes. So in the previous lesson, so in lesson 15.2, we were actually finding theoretical probability. We were just talking about the number of both favorable outcomes out of the total of possible, and the fact that they're all should be equally likely. Okay. This one that we were just talking about is given an experiment. So this depends on what happens when you do that experiment. Theoretical is what you should expect. So in the case when you were rolling that dice, like I said in example 1, I would think, and what I would expect, is 25 out of 50 because you're taking 3 of the numbers. I would expect that. That's my theoretical probability. This, though, is different because this is an experimental probability. Again, the theoretical is going to be what you would expect. Experimental then is going to be what happens based on the actual experiment that you do. Okay? So let's go ahead and look at some examples. So here is one. It says you randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? So this one, again, I didn't actually have an experiment. It didn't say, hey, okay, So you picked up 20 blocks, and of the 20, 10 were vowels. This one is just going to tell me what is my likelihood or my chances of picking up a vowel. So again, it's going to be the total amount of blocks on the bottom out of the total amount that are vowels. So we have 1, 2, 3, 4, 5, 6, 7 total blocks. Of those 7, my red ones here are all vowels. So those A, E, I, O, or U, and sometimes Y's. So I would have 3 out of 7. We can't simplify 3 out of 7, so my theoretical probability is just 3 out of 7. All right. So then, example 4. Theoretical probability of winning a bobblehead when spinning a prize wheel is 1/6. The wheel has 3 bobblehead sections. How many sections are on the wheel? Okay, so if, winning a bobblehead when spin a prize wheel is 1/6. Okay, so we're going to have to set up our proportions here. So we're going to have 1 out of 6 equals, okay, and we're going to set them equal to each other. Now, the probability of winning a bobblehead is 1 out of 6. And most of the cases when we've been setting proportions, we've been filling in the other number they give us at the bottom here. Because they'll be like, hey, you spin the wheel 12 times. How many bobbleheads would you win? Well, this time it says the wheel has 3 bobblehead sections. They want to know how many sections are actually on the wheel. So this 3 is going to go at the top. So I actually want to figure out what's on the bottom here. This one, again, is an easy one where I can find this pattern. I'm multiplying by 3 from one to the other. So I'm just going to take the 6 and multiply it by 3. 6 times 3, that gives me 18. So on my wheel, you would have 18 sections. Okay, so biggest part is being able to read these and decipher where these numbers are going. Okay, so being able to read them. Think about the 3 wasn't the total possible outcomes. That was only the possible of winning. That's what we wanted, so we're putting it at that top. Okay. Keep going. All right, we got more for you to try on your own here. And I think, oh, we got another example here then afterwards. Okay. So why don't you go ahead? I'm actually going to just move this right into the next video. So this video is going to end. I want you to be able to answer these 3 questions. Okay. When you come on back to the next video, then I will have the answers for these ones. So please make sure that you are checking in for part 2. Don't worry. Keep checking for your code word. I may have said it. I may have not said it. Okay. So I will catch you in part 2 and we will finish off the rest of this lesson. See you in just a bit.